Welcome everybody to the first non-keynote day one of the first ever HashiConf. My name is Justin. Talk this morning is Operating Console as an Early Adopter by Nelson Elhaj. Nelson is a tech lead of the systems team at Stripe. He works on all aspects of systems infrastructure and has driven the adoption of both Consul and Vagrant at Stripe. So please give a round of applause for Nelson.
Hi, everybody. So as this title says, today I'm going to be talking about the experience of specifically operating Consul as an early adopter. I think we're probably all here because we love HashiCorp products. We're fans of some of them. I'm a big fan of a lot of the HashiCorp products, but like any product, when you pick up a new software product in an early stage of its life cycle and you try to put it into production, you throw it in a production environment with hundreds of servers that's serving real traffic, and it hasn't really, no matter how good the developers are, they haven't tested it in your environment. It hasn't been tested in that many big environments. And sometimes things go wrong. And so we just heard from the keynote about lots of success stories of lots of big customers using HashiCorp products, using Consul in enormous clusters. I'm here to tell you the things that Mitchell won't about what happens when you're one of the first big users to put Consul in production. And I want to be clear at the outset here, I'm a big fan of the HashiCorp products. I'm a big fan of the company. I'm a big fan of Consul. We run it in production. But I'm going to be telling you a lot of horror stories about what happened when we tried to put it in production. And I'm going to try to close with some lessons and takeaways that you can use when if you put hopefully Consul is more fully baked than when we started. But when you put any HashiCorp product or other product into production that's relatively early, some lessons you can use to minimize the pain, damage, and uncomfortable 4 a.m. calls on your way to having a stable, productive deployment of whatever it is. So we're going to start with, I'll be sort of alternating, telling you stories of the rollout of Consul at Stripe, as well as some war stories and the horror stories of what happened, what went wrong, and what went well. And then we'll conclude with a coda of lessons learned and some of the takeaways from my experience and from what I've generalized from that, and lessons that you can take to your next deployment of some new, relatively untested software in production. So, Consul at Stripe. Stripe, if you don't, as mentioned, I'm the tech lead on the infrastructure team at Stripe. If you don't know Stripe, we're a payments company in San Francisco. We do online payments. If you're running a business, you want to sell something online and accept credit cards, we aim to be the easiest, best way to do that. We're pretty big and we're relatively successful and have lots of customers, move billions of dollars a year, et cetera. And in early 2014, we were, our infrastructure, as it does as you grow and try to support more users and more products, et cetera, was gaining complexity. We really needed a service discovery solution, a host inventory solution that would let our systems discover each other and configure each other in a more dynamic way than our existing solutions, which were basically a hodgepodge of hacks involving primarily stuff distributed via Puppet to populate flat file config files in various places, which worked but was a pain, had a lot of latency whenever we made infrastructure changes or rolled new things out. Some engineers had started an abortive effort on an in-house service registry built in Ruby that was just both a developer and operational nightmare. It sort of got just far enough along to become a production dependency, and then the developer stopped working on it. And we wanted to replace all of that with something. We looked around, we looked at what was available out there, and we decided we settled on Consul. We decided to give Consul a shot. Why did we choose Consul? Well, there really isn't that much out there in this space that's off the shelf. A lot of peer companies that I've talked to end up building something on top of Zookeeper. That has the merit. The Zookeeper is extremely well battle tested in production. Zookeeper is not a service discovery solution. It's not really intended as a service discovery solution. A lot of people have built solutions on top of it. Few of them were open source. A lot of them were very heavily specialized. Also, we had no experience running Zookeeper, and consistent reports are that if you run a Zookeeper, there's like this year of pain in which you learn how to run and operate a Zookeeper and nothing works right at all. And once you get over that, it's rock solid and stable, but then it has this enormous learning curve to figuring out how to operate it. And Consul, we were aware that it was a little bit green, that it was going to be a little bit rocky, but it had the feature that everything we wanted in terms of host inventory, host discovery was baked in out of the box. We wouldn't have to build software around Consul to solve our purposes. We could just deploy Consul and use it more or less as is. And that was extremely appealing. So we started by doing some test rollouts. We rolled out Consul across all of our servers. We started with a rollout in our QA environment. We just verified that the agent would run everywhere and talk to each other, and the Raft cluster would elect a leader, and we poked at some things by hand. We had no dependencies on it at all initially. It was just like, let's get it running. Let's observe it with little in a low-stress environment. This is going to be a recurring theme of you want to roll these things out very incrementally. You want to figure out what's the minimum test that I can do to get this thing into production and get some confidence that it's working without just immediately jumping on board it. And even in the process of rolling it out initially, we asked the question, all right, what's going to go wrong here? As a footnote, anytime anyone asks what could go wrong, there's going to be a postmortem at some point in the future where you're going to go back and be like, oh, that's what went wrong. But you should still try to think ahead. We had no clients depending on Consul, so we weren't really worried about Consul not working, because if it didn't work, nothing depended on it. We were just trying to burn it in. So we were asked, what could go wrong so badly that even with no one using Consul, it could bring down the site? And the answer we came up with, thinking about this, was we were really worried about memory leaks. Because the Consul agent was going to be running on every one of our servers. You could imagine some hilarious bug where there's like a surf gossip storm causes an unbounded amount of surf buffers on every machine in the network. Every machine in our entire data center swaps itself to death. And we're just like, fuck. This didn't happen, but we were worried about it. So the first thing we put in place was we added monitoring for memory usage of the Consul node. We added a Nagios check that looked at the memory footprint of the Consul agent. The hypothesized surf gossip unbounded memory leak of doom did not happen, but this Nagios check for memory usage of Consul turned out to be a surprisingly prescient decision on our part. So shortly after we had it in production, we had our first production incident. It was a pretty small one. We tuned the check based on some random guesses. We noticed that one node was taking more than twice as much memory as anyone else. We're like, oh, that's a little weird. It's not like 100 megs of RAM. We can afford that, but this seems odd. We'd reached out to Armin. We'd been in contact with him. He wrote much of Consul. I first met him at GopherCon last year, and he was aware of our deployment, and him and the other HashiCorp folks were very happy to help. We reached out, we poked at the stats, and we found our first bug in production. There was a race condition in the stats framework that Consul used to record stats, that it's supposed to keep a rolling window of the last 10 seconds of stats, of metrics, so that it can report them to stats to your dumped the logs. There was a race condition where it was recording every stat that it had ever recorded since the start of the agent in memory forever. And it didn't cause any problems, but it was a nice, it validated a lot of our assumptions that we're right to be careful with this. There are going to be some issues, but that they can be managed if we're looking for them, if we're proactive. The fact that we had the memory check meant that we noticed this well before the node ate up all of the memory on the box. So with that little bit of confidence, with it running in production, we started adding clients to our environment. We started adding dependencies to Consul. The first thing we added it to was our deploy tool. This is the central orchestration tool that pushes new builds out to app servers. Previously, it had relied on getting a list of hosts from Puppet that would tell it, okay, the API should deploy to this set of API machines. But of course, periodically, people would rebuild the API machines, or we would add new API machines. The deploy tool hadn't been puppeted yet, and we would have deploys to a stale list of hosts, or to hosts that didn't exist anymore, and this would cause errors for developers. It's a pretty common story with these kinds of situations. So we hooked it into the deploy tool. We kept a manual fallback that would fall back to that potentially stale host list. We also started doing some experiments with generating load balancer configs for our HA proxy via Consul. Again, previously that had come from Puppet. This had the nice property that we were just generating configuration files on disk. So if we had errors or whatever talking to Consul, we would just signal the error and run with the old file, and we'd sort of be no worse off than our old Puppet world. And this all worked in testing. We rapidly noticed that these things would fail surprisingly often. They would get an error talking to Consul. And we started poking at logs, we started poking at some metrics, and we noticed a huge amount of instability in the Raft cluster. The Raft consensus algorithm works by electing a leader, and then the nodes basically constantly health check each other. If a majority of the network thinks that the leader is down or unavailable, they hold a new election, they elect a new leader. during this election process, there is no leader, and requests that go to the cluster with default options will fail because they can't get to the leader, so they can't guarantee consistency. And we were seeing failovers happen at least once a minute, and they happen pretty quickly. Consul's Raft implementation does leaderships fairly expeditiously, but even if they take 3-5 seconds, that happening once a minute, that's a large fraction of the time that Consul is down and unable to service requests. We reached out to Armin in the mailing list. We learned a very important fact that we hadn't realized at this point, which was that Consul at this point in time was just not at all optimized for spinning disks. We'd spun it up on some pretty small EC2 instances that were using spinning disks, and the answer we got was like, oh no, that's you're going to get disk timeouts, and that is going to cause what you're seeing. Consul is at present really only been tuned for SSDs. And this was not in the docs or anything. This was just sort of an assumption mismatch between us and developers at this point. We also received the advice that we were on 0.2, we should upgrade to Consul 0.3, and that had some improvements in the timeouts and performance. So we took that advice, and we rolled out 0.3 to our QA cluster, and nothing worked at all. So we were using Consul with its TLS support, so that all nodes had TLS client and server certificates that they used to authenticate communication with Raft. And when we looked at the logs, we noticed that every single attempt for any node to communicate with anyone else was failing with the TLS verification error. We did some digging. We discovered that 0.3, following on the tail of a change in the Golang standard library, changed TLS verification to check the certificate name. Previously in 0.2, it just verified that you handed it a CA, and it verified that every node in your network was signed by that CA, but it didn't actually look at the server name on the cert. 0.3 changed this. So we're like, okay, fine, that's kind of annoying, but that's a reasonable decision. We changed our SSL infrastructure to add subject alternative names to the cert that matched the Consul node names. We roll that out, still doesn't work. We look at the logs, we see errors of this form everywhere. Failed to make request vote RPC as a certificate is valid for remote host's name, not local host. So I'm trying to talk to a remote host, and I'm getting an error because the remote host certificate is valid for its host name and not for my host name. 0.3 had a bug as released, where if you used TLS, it would validate that every remote host that you talked to matched the local host name. HashiCorp had run into this in their test deployment, and they added a configuration option that would just force every node to the same host name, and every single node in HashiCorp's demo cluster was running using the server common name of demo.console.io. So that was a little unfortunate. This didn't break us in production because we tested in QA first, but this is a good lesson on the merit of doing rollouts to QA first. We ended up writing our own patch that would restore the 0.2 certificate checking behavior. We experimented with making the hostname checking correct, but decided it didn't really make sense because the Consul gossip cluster model didn't really match with the DNS model that SSL certificate names are designed for. And the semantics we really wanted, and that we suspect most people wanted, were the 0.2 semantics. So I ended up writing that patch, and Armin very quickly reviewed and merged it. We were able to roll forward to 0.3.1, which was 0.3, with several bug fixes, including that patch. We upgraded to SSD-backed servers, and the Raft cluster was basically happy at this point. The cluster was able to maintain consensus, maintain stable leadership for minutes at a time. So, with some more rocky ground behind our belt, but again, slowly improving understanding of Consul, improving understanding of its failure modes, and improving faith in its stability. It now did actually maintain leadership and would fail over at most a couple times a day, which is pretty normal for almost any consensus-based system, because there are trade-offs in the timeouts that you set and the vagaries of network infrastructure, et cetera. A couple failovers a day for something like this is pretty okay. So we switched a bunch of our internal operational tools that, again, depended on host inventories to pull information from Consul. We switched our main application, the Stripe API, started using Consul at startup to discover some of its runtime dependencies. It would cache this information, so it wouldn't talk to Consul at runtime. So in the event of a Consul error, we wouldn't be able to start new app workers, but the existing workers, existing processes would continue running, and our deploy processes would fail safe, and the site would remain up, and we would have time to fix the problem. And that mostly worked. It was great. It let us remove a whole bunch of YAML files generated from Puppet from our hard disks that had to be manually puppeted around whenever anything changed. We discovered in this process that consensus is hard. How many people here have read the Raft paper? The Raft paper, if you read it, it's all well and good, and there are a number of assumptions in the Raft paper about the ratios of relative timeouts, the network timeout versus the leader election timeouts, et cetera. Consul has hard-coded into it some assumptions about those timeouts. Those assumptions are mostly accurate most of the time. Sometimes they're not. When they're not, things go bad. We saw a couple of issues where the Raft cluster would just get in a state where it was election storming. It would elect a new leader, the leader would step up, the leader would immediately step down, it would elect a new leader, and this could go on for hours at a time of just totally failing to elect a leader. We would have to run around and bring down a bunch of the Consul agents to stop the traffic storms. Then the cluster would stabilize, and we could slowly bring things back up. This was a real pain. While this was happening, no new processes anywhere in our app could start, so we were in a bit of a fragile state. It's never caused major downtime of our app because of the safeguards we put in place, but it was a pain. We upgraded it. We were told once again to upgrade Consul again. Something of a recurring theme here. We go to HashiCorp and they're like, oh yeah, there's some timeouts, performance issues, just upgrade. We've probably fixed it. And most of the time they were right, to be fair. But so there were some hard times here. Around this time, HashiCorp released Consul template. They started rapidly iterating on that. We switched a bunch of our in-house configuration generation scripts that had been hand-rolled against the Consul API to use Consul template. We discovered very rapidly a couple of awkward issues in Consul template. I think issue 168, which I filed, was my favorite one. If you had a Consul template file that rendered n services, and we had at this point a couple of hundred services registered in our cluster, and we had one main load balancer config that would read from most of them and set up HA proxy config. Rendering n services would take n squared amount of time from Consul template, and in particular, it would generate n squared log messages to the Consul log. So running Consul template over a relatively short config file that generated output for 70 services or so would generate 1.5 megabytes of log traffic, in addition to spinning a huge amount of CPU. We were able to get that issue fixed, fortunately. Again, we iterated with them. They were very responsive on the ticket. So we rolled out, so that fixed. We had HA proxy config being generated by Consul template. We rolled that out into production. For reasons that present me doesn't understand, past me decided that a Friday afternoon was a good time to enable this. We turned it on, things seemed to look good, and then Consul just fell the heck over. And we started looking at graphs, and we could notice very clearly, turn on Consul template, like here's Consul's memory allocation rate. I unfortunately didn't save the graphs from the time, but turn on Consul template, whoop, turn off Consul template, drops down. And it was churning through millions of allocations a minute. And this is the point at which we learned a dirty secret that was, I think, understood by some people, but not really publicized, which is that Consul's service watches, the feature where you can register a watch and say, notify me when the service registry changes, they don't really scale at all in the current implementation. Like, not even a little, unfortunately. Basically, we were watching 70 services, so that way we already had 70 concurrent HTTP connections to the server. And whenever any service anywhere in our cluster, again, this is a couple hundred node cluster, a couple hundred services, whenever any node flaps its availability, any new service comes up or whatever, all 70 of those watches would be triggered. The server would push 70 changes back to the client. The client would immediately kick 70 new watches into place. And these would just thrash, several times a second. And Consul template was self-DDoSing our cluster. And unfortunately, this is something of an architectural issue in Consul as it stands right now. I'm promised that 0.6 will hopefully improve the situation, although I don't yet know if it'll make it usable on our site. But so using console template with watches basically was just completely untenable in our infrastructure. So we switched to using console template in -once mode, where it just pulls all of the dependencies, generates the templates, and exit. We run that in a cron job once a minute or so. So this means we have worse latency than we might to pick up changes in the cluster, but it works very reliably. It gives us a convenient mechanism to suck data out of console. So now at this point, we were relying pretty heavily on console. We were dumping things into templates. We were talking to the API at startup to discover dependencies. We started to branch out a little bit in our usage of console. Our data team was building a system where they wanted a leader election primitive. They wanted to have 2 or 3 copies of a service running, but only one of them be the leader and actually be making progress, with the others just doing some secondary work and waiting in case the leader fell over. Console has a feature that's designed for this, the console sessions and locks, etc. So we said, sure, let's build that on top of console. There's example code that's already available for you. And they did that. We built the example code. It was pretty great. It worked well. You know, they could run 3 instances of these. One of them would step up and take the leadership. If it went down, one of the other ones would seamlessly step up. And we're like, great, this is exactly what we wanted. A leader election primitive is a very powerful thing. And so that was cool. Some point later, we noticed that our cluster was getting unhappy again. By this point, this is the first graph I have, because at this point we had console hooked up into our statsd cluster. Console has had stat site support, which is Armin's C-based statsd fork or statsd implementation support. It didn't have statsd implementation because statsd only spoke UDP, etc. But so there was, and also in console 0.2, I think the configuration option to configure stat support was present, defined in the code, and not actually wired up to the code to emit stats in the back end. It just didn't work. The rough edges of running 0.2 software. But we were successfully hooked up to Graphite, and we noticed this. This is the number of Go routines, which if you don't program Go, you can think of them as threads that were running in the console server. And they were just going up. You can notice that the axis here is on the scale of hours, right? Within the scale of 2 hours, we're getting 10,000 new threads. And the memory footprint of console, similarly, was also just going up. Once again, that Nagios check we'd put in for console memory footprint turned out to be very useful because it alerted us to this before the site went down. But something was going terribly wrong, and we were triggering a hideous memory leak in console. And of course, once the console eats a lot of memory, in addition to eventually, ooming the box or taking it down, the larger heap would lead to larger GC pauses as the Go 1.3, or I think probably 1.3 at this point, GC would try to churn through all of that memory. These random timeouts would lead to raft instability, and console was basically borderline working again. While we debugged this, we were in a state where we were manually restarting the cluster once a day. We didn't want to automate this because the cluster was kind of delicate. We were worried that if it just restarted everything in the middle of the night, it might not come up again at all because of some of the previous instability issues we'd seen. So for a while, just whoever was on call would just once a day log in and handhold the server through rolling restarts, which is not a pleasant place to be. We reached out to HashiCorp again. We sent back and forth lots of stats and logs. They were very helpful. They found and fixed multiple memory leaks in console. None of them was our memory leak. We spent more time diving in and correlating the start of this terrible memory leak with deploys to our code. Unfortunately, our logs and our systems for correlating these were not as good as we would like. But eventually, we tracked it down to there was a session leak in our leader election code that was leaking sessions. And it was leaking them at a relatively slow rate, and that was somehow ballooning in a crazy way on the console server. So it was still a bug in console, but it was triggered by a bug in our code. With that report, we were able to hand a reproducer off to Armin and the HashiCorp team, and they were able to fix the issue. We were also able to fix our bug and fix our leader election code. But this led to a new internal policy at Stripe about our use of console. We decided that, as excited as we were about the console key value store as a possibility for distributing configuration and about the possibility of console as a lock server or leader election mechanism, the reason we had originally gotten into console was because we needed a service discovery node, we needed a host inventory solution, and we decided to draw a hard and fast line of that was all we were going to use console for. We would love to be able to use these other features. I think at some point in the future we will revisit using them again, but for the sake of having a stable, predictable production system, in order to minimize our exposure to just the potential bug surface of Consul, we decided that those features were just out of bounds. Our developers, our operations people weren't going to use those features internally. We were just going to use it for service discovery, because that would minimize the scope of things that we had to learn about. So with that fixed, Consul was still pretty reliable, but we'd picked up our share of battle scars at this point from the Raft cluster, and we'd also learned, which we'd always known, but Raft is fundamentally a CP system. It's consistent, but it's not always available in the presence of network partitions. And network partitions in the CAP paper sense include such things as GC pauses or disk pauses that can just pause nodes. And fundamentally, for service discovery, we wanted something that was always available but potentially slightly stale. And using Consul's built-in staleness mechanisms to query followers in the Raft cluster wasn't quite satisfactory, because our experience suggested that sometimes we had to bounce even those and bounce local Consul agents to return stability to the cluster. So we were pretty happy with the state, but periodic instability was painful. We designed our systems so that, as much as possible, outages didn't bring the site down, but they were still causing pain and lost sleep for operators. So the next step for us was we developed a Consul template file that would compile the entire Consul DNS registry. Consul has a DNS namespace into a zone file. And rather than pointing our DNS mask at Consul's own resolver, we would compile a Consul template to a zone file, serve that out of a real DNS server, and we would periodically refresh that via a Consul template job. And this was pretty nice, because it let us preserve the Consul DNS interface, which is a very handy interface. It's useful for plugging into a lot of things, but it isolated us from the instability of Consul. And I think there's sort of two ways to look at this solution. I think one, it's possible to look at this and regard this as a failure of Consul, if we sort of had to work around it by compiling the DNS to a file and rather than using the built-in feature. And that's true to some extent. But on the other hand, it's a choice of just taking the trade-offs that were right for us and the trade-offs that were right for Consul were different. And the fact that Consul had this built-in DNS scheme that someone else had designed, we were able to preserve that same API of the same set of DNS names, the same way that they worked. And so we did end up having to do more work than we would like, but the fact that the Consul developers had already designed this interface for us that was a reasonably well thought out interface and that was sort of narrow enough that we could re-implement it was very helpful. It meant that we didn't have to sit down and design the same interface and think about what's the right way to map these concepts onto DNS. And it also means that if in the future, we again trust the availability of Consul, they get better at being available during outages in the ways that we want, we can potentially undo this and go back to just the native Consul solution. And so that is basically where we are with Consul now. We run Consul across all of our clusters, all of our services, all of our internal services, and we still have a fairly monolithic Ruby app, but we're moving pretty strongly towards an increasingly microservice world. And also all of our internal databases and queues and other third-party software like our Redis or our SQL database or our Elasticsearch are also registered in Consul. And essentially all internal discovery happens by way of Consul. A lot of stuff, and in particular anything that happens in the request path for our public-facing services, we try to use the DNS interface, and those hit that cached DNS zone files on disk, which are served by our existing internal DNS infrastructure, which is very robust and very redundant and reliable. Our internal operational tools, the tools that we use when we are bringing up new machines in EC2, rebuilding machines, replacing machines, auto-scaling, scaling capacity internally, those things tend to hit the HTTP interface. That gives them reliable source of truth. Those tools run more infrequently so they can tolerate brief transient outages in Consul. And we also have a number of places that generate configuration files on disk using Consul template. This includes all of our load balancers, our frontier load balancers that load balance to backend services, generate HA proxy config using Consul template. And we have some other third-party apps we have to run that have to have flat file configuration files. We also generate via Consul template. And I just wanted to leave a final note. I've given you a bunch of horror stories about the hilarious ways this failed. All of the memory leaks that we found and reported were fixed in 0.5.2. All the ones we reported and several we didn't report, and to my knowledge, there are no outstanding ones there. Consul's been very stable for us for months now. We have graphs that show us when there are elections, show us performance. I check them occasionally, but there's nothing of note. Consul service watches still do not scale and are completely unusable in our environment. I've been promised that ODA 6 should help, but that's not out yet, so I can't speak to that for certain. But on the whole, we're in a pretty good place. It's been a bit of a rocky road, but now we're reasonably happy with where we are. We're still skittish about pushing more things to use the live Consul API, but that's fine. Having the cached DNS solution has a lot of the properties that we want out of a service discovery solution. So that's our story. And now I want to step back a little bit and reflect on some of the things that I said and try to condense some of the ideas and experiences we had into a sort of a handful of bullet points of useful lessons to learn when you're, both specifically if you're going to adopt Consul, if you're going to adopt another HashiCorp product, if you're going to adopt any new product, especially things that are relatively newer where you're going to be one of the first larger users, but even things that are well established but you don't have a lot of experience. How do you bring them into production without bringing your site down too many times at least, for too long? And so focusing again on early stage products like Consul was for us. I think the first thing that I have to say is know what you're getting into. We chose Consul, we chose Consul because of its feature set, because of its interfaces, because it provided out of the box something that we'd probably otherwise have to build. But we knew that it was relatively young and untested, and we were prepared for we're going to be fighting a number of battles over the coming months as we integrate this into production. That was a choice that we made. I'm happy to argue at lengths over beers later with anyone about whether or not that was the right choice. It's worked out reasonably well for us, but there was a lot of pain. But we made that choice knowing that there was going to be pain. Next bullet point, monitoring. If you work in operations at all, in infrastructure at all, you probably already believe this pretty fervently, but monitor everything you can, graph everything you can. The point is not to read these. These are the 3 separate Grafana dashboards that we have set up for our internal Consul, graphing literally every metric that Consul is able to output. It's prioritized, like the things near the top are the things that we're more likely to care about, but we have a graph for anything. Whenever anything goes wrong, anything changes, we look at the graphs, and very often you can just be like, oh, like this problem correlates with that line changing, and that gives you a lot of information to try to root cause what the heck happened. So having as much visibility into graphs, having log aggregation so that you can stare at your logs, you need that visibility, and you need to be able to share that visibility in some way back with the upstream developers if you're working with them. Whenever I reported a bug to Armin, basically the first response would be, can you send me an output of all of the Consul stats during the incident, because that will point us at what happened. Roll things out incrementally as much as you can. Have burn-in periods where, like, initially we rolled out Consul, we didn't depend on it at all, we just rolled it out and watched it and saw what happened. Start with non-critical services, start with things that are internal tools that only a few developers use. Don't roll things out and shove it straight into your API request path. That's a recipe for pain and sadness. Have fallbacks. It's a little bit painful, but if you're using a tool to replace an old tool, keep a feature flag, a command line flag, whatever's appropriate for the environment that'll flip between the new thing and the old thing, so that when the new thing breaks, you can fall back to the old thing. Once you've gone a month or 2 or 6 months, depending on your scale and the severity, et cetera, without having to flip back to the old thing, then you can think about deleting the code. Don't just cut over. Limit the scope. Consul has a lot of features. I'm excited about a lot of the features, and I'd love to be able to use them, but we made the decision for our own sanity that we wanted Consul for service discovery, and that's the only thing we're using it for right now. We might revisit that more once we're more stable with it. But if you're adopting a new technology, make sure you understand why you're adopting it, what you're adopting it for, and don't just go hog wild using all of the features that you can. If you're going to deploy an app in AWS, that doesn't mean that you have to use every single Amazon hosted service that you can possibly justify. I had a friend once who specifically was working on a service as an intern at a startup, and they sort of gave him a blank slate to design it because it was a very early startup, and he specifically made a game of trying to use as many Amazon internal services as he could, just so that he could get some experience and familiarity with all of them. It was a great experience for him, but the year after he left consisted of engineers who were still there, because he was an intern, was gone now, gradually replacing one after another of them with more consolidated services in places where they didn't make sense. Isolation, try to isolate yourself from failures as much as you can. Plan for failures and think about them. Caching things in memory or caching things on disk with Consul template was a technique we used. But think about failure and ask how you can isolate failure. Upgrade software aggressively. This one is really counterintuitive if you work in operations. If you work in operations, probably your instinct is never change anything. It's going to break everything. And again, we can argue about whether that's a healthy attitude or not, but for young software that's changing and maturing aggressively, that's the wrong approach. Consul 0.2 isn't Consul 0.2 because HashiCorp went through a burn-in and stability period and is confident there are no bugs. Consul 0.2 is Consul 0.2 because they added some new features and decided to throw a tag on it and encourage people to download it. And that's fine and normal, but that's how early stage software development goes. And it's quite likely that even the bleeding edge Git master is going to be more stable than a release because it's just not mature enough to have a real stabilization process. As it gets older now, like with 0.6, we're not going to jump straight on that one. That has a lot of features, but also they've spent more time stabilizing and releasing point releases. But especially early on, upgrade quickly. It helps your relationship with upstream. When you report bugs with them, if you can be like, yes, I'm running the latest master, they can be confident that they haven't already fixed it. We would periodically say, like, we're on 0.3, this is 3 months old by now, and the response we get is, oh yeah, that subsystem has been completely rewritten, that bug is probably fixed in master. And that, again, comes to a recurring theme that I've mentioned all along of if you're going to run new software, get to know your upstream, get to know the developers, the people who are writing it. I first met Armin at GopherCon, and we discussed Consul, and I mentioned that I was interested in rolling it out. We've been involved in the mailing list and on IRC, and I've gotten to know Armin, and he's been very helpful about whenever we have issues, we just reach out directly to him or the mailing list, and they're very responsive. If one of the downside of being an early large adopter of software is that you're going to hit a lot of things first, the upside is that the developers, if they're any good, they care a lot about you, they care about your problems, they care about figuring out how to fix them, they care about making the tool better. And having a close relationship with them helps a lot because you can go to them when things go wrong and they will help you figure them out. Also, relatedly, if you're going to adopt something early, you have to really be willing to dive in and get involved. You can't just deploy it and hope that it works. You have to be on the mailing list. You have to read the mailing list. You have to know the developers. You really, ideally, should have you or someone on your team be willing to dive into the source, get to know the source code a little bit, write the patches. I've written many patches for Consul at this point, mostly small bug fixes around things that we run into. But being able to do that for yourself means that you can fix your own issues much more quickly than you can. With Consul template, when I found the order n squared 1.5 megabytes of log bug, I was the one who diagnosed that and wrote up I hope it was well-written bug report that helped upstream figure out what was going on. It's perhaps more effort than just like running something and hoping that it works. But if you're going to commit to running early stage software, you have to be willing to get underneath the covers and help yourself. All right, that's pretty much what I have. That's the story of the rollout of Consul as an early adopter. If anyone else is thinking about rolling it out, I want to emphasize that we started at 0.2. It's several significant releases above that. You will not run into most of the problems we ran into. You will probably run into new and exciting problems, and I hope you do, and get them fixed and document them. Then those are my thoughts finally on how to roll something out as an early adopter at scale without getting bitten too hard. And I'd love to discuss either of those topics with any of you. We've got some time for questions, I think, and then I'll be around.
If you have a question, if you could line up the microphone, that would help.
All right, thank you so much. Interesting talk. My question is, the latest console version still requires SSD for the reliable service. And the second question is why the consensus algorithm implementation of console depends on the disk performance.
So console, I know that there's been a lot of tuning in console since 0.2, and I don't know if it still requires SSDs for stability because we've just switched to SSDs. In the early versions, the reason it required fast disks for consensus was that was basically the flushing of the Raft log to disk was tied into the same loop that serviced heartbeats and serviced keep alives. So if there was a disk pause, then the node would also stop responding to health check requests from the other node, which meant that a slow disk would manifest as a node appearing down. Since then, I believe they've decoupled those processes so that the network processes are decoupled somewhat from the disk processes, and it should be more resilient to transient disk hangs. But we haven't. I can't speak authoritatively as to whether it's recommended. It's now recommended or sort of believed to be fine to run it on spinning media.
Hi, I'm Mark. Thanks for giving this talk. For both you, Stripe operations team, and HashiCorp, it's a courageous talk. I think it embodies fail fast, fix fast in many ways. So the question I have is, now that you've had your teething pains and you're continuing on, right, which is a success story in of itself, have you considered what it would take to kind of go to test-driven operations or improving the test suite of consoles so that you can predict some of the failure modes that you're working against, such as, the recursion in all the watches, right, and so on.
Yep.
Have you started going to test-driven operations as a strategy? Because I think that may have been, this is a philosophical question, I think, right? But it's how to evolve engineering past, we're going to try it out in operations, we're going to, mitigate the risk as much as possible. How can we get to a proactive situation where we're actually developing operations?
Yep. I haven't. I've given it some thought. It sort of obviously would be nice to have easier solutions. I don't. For a lot of the problems that we have here are very fundamentally related to the scale that we're running it at, which is not enormous, but is sort of is larger than it had been tested at. I don't feel like I have a good mental model of how you might test some of that stuff in an environment. Although one of Kyle Kingsbury, aka Afer of the Jepsen blog post series, actually does work at Stripe. And he works basically full time on testing distributed systems, both for internal use and externally. He hasn't personally, and HashiCorp did point his Jepsen tool at Consul when they pre-release. He has some objections with the testing that they did. It was better than nothing, but they could have done a better job. But I'm very excited about his work in testing distributed systems. He hasn't pointed his tools at Consul, and they aren't specifically designed currently to reveal the kinds of problems that we had. But that's one space that we as a team and as an industry are starting to look at testing these things in a way that we hadn't before. That's pretty exciting.
Cool. Thank you.
But I don't have any good thoughts on how we would have uncovered the kinds of problems that we have via testing strategies that sort of aren't prohibitively large scale. If you do, I'd be very curious to talk.
Okay, thanks.
Hi. So we're also Puppet users. We're not actually using Consul as yet. One of our weak points, I think, in our Puppet ecosystem is mcollective, which we're kind of using for some of the service discovery stuff that you're talking about. I wondered if you've tried ConsoleExec for that, whether that's a sensible or a crazy idea.
ConsoleExec is on that list of features that we've just decided we're not going to use. We have existing mechanisms for cluster automation because we have a large and robust cluster that's already existed. We looked at we sort of were abstractly interested when ConsoleExec came out, but obviously we had a lot of concerns about potential security properties. It integrates with the ACL system, et cetera, but that's all relatively untested and unaudited. It didn't solve a problem that we had, and there were obviously concerns around it. So I haven't looked into that at all.
Okay, thank you.
So I had some instability problems with the DNS as well.
Yep.
The resolution, and I worked around that by putting in a local caching server, caching resolver
Yep.
inside each of the machines and having multiple entries in the resolver to point to itself. So like retry multiple times. Did you have like a problem when generating the zone file? Like, when it had problems resolving, it would like, output incomplete zone file. Did you have any problems with that, or?
We haven't had problems with that, and the way the way console template works is that it'll run through all of the queries and build up the results in memory, and only if the entire process is successful will it write the file to disk.
Right.
So if console goes down during that process, it will just fail and then try again in the next window. We haven't seen problems where console will for instance spuriously exclude nodes from the output. We have not seen problems of that nature, and so we've found the console template zone file to be pretty reliable.
I see. Okay, thank you.
That's great. This is sort of kind of a follow-up to what he was asking about, actually. So I know with the DNS, with generating that DNS file,
Yep.
how often are you doing that? It's like, so at what approximate like refresh rate? would you be?
Currently, it runs every 15 seconds.
Okay. So TTL on the DNS records?
I forget how exactly we're configuring things right now.
Okay. I was curious because it seemed like that was sort of one of the advantages, being that you can hit it all the time. You don't have to worry about the life expectancy of the information. But
Yeah.
if you're constantly regenerating the file, I was thinking that would. I was curious.
I mean, like the file is constantly regenerated on a central set of DNS servers, and every one of our nodes runs a local DNS mask that knows about all of the upstream DNS servers. And so the local, if we do set TTLs on these things on the order of 30 seconds. I forget exactly how we have it tuned right now. And so records also end up getting cached on every application server in the local DNS mask. And then the local DNS mask knows about all of the upstreams, we're robust we're resilient to failures of the upstream DNS, which is like a pretty standard internal DNS architecture. And being able to just bootstrap the console stuff into that was pretty convenient.
Thanks.
Thank you for the fireside chat. That's great. So first question is, what is your memory footprint now that things have kind of stabilized for the console?
I don't remember. Less certain. So for the agents, the ones that run on every server, it's definitely sub 100 megabytes. I forget exactly where it is in that range. The servers, because they store the entire RAF database, et cetera, it's somewhat larger, but it's I think not more than a couple hundred megs.
Okay, and does that scale as you add more nodes and clients to the system?
It should. It shouldn't, and I don't believe it does, because most of the store is stored in the previously LMDB and I think now BoltDB store on disk, and so the entire RAF database is not reified in memory.
Okay, and my second question is, how often are leader elections occurring now that you have stabilized?
Something like once a day, I think. Currently,
Okay.
I haven't looked at numbers recently.
Okay,
but,
so
and
very
that's-
reasonable though.
Right. So that's like 3 seconds or so of unavailability of strong consistency queries, and most of our clients now also use the I forget what exactly Consul calls it, but the consistency mode that lets you get answers from followers as well, as long as they are within a couple of seconds of the leader. So even during those incidents, we're generally able to fetch data still.
Okay, all right, thank you.
Thanks for the talk. My first question is roughly, can you give us an idea of how many nodes you're running, multiple data centers? Are you using the multi-DC stuff?
We are using multi-DC. We have three DCs, total of like somewhere of order of 1,000 servers.
Okay, and the second question is, it sounds like you're using Consul template. Is Consul template running locally on all of your nodes with the Consul agent, or are you only running it on the DNS infrastructure?
We're running Consul template on a small number of central infrastructure nodes. Like our load balancers
Sure.
run it to generate HA proxy configs, and the DNS template we run on our central DNS servers.
So why are you running Consul agent then on all of the nodes, if you're not actually using the?
We use it for. Consul agent on all of our nodes still does health checking of local services and gives us their service inventory. That's how Consul discovers what's available. And then some things also, like I said, some of our internal operational tools talk to the HTTP API. But running Consul template on all of servers is still how Consul maintains the service and node database and keeps that live.
Thank you.
That's all the time we have for questions. Thanks again to Nelson.
Thank you.